Hi, this is Chris Armstrong from Rigol Technologies, and we're here talking about power consumption for your IoT device and how Rigol can help you estimate battery life and optimize for power throughout your IoT design cycle. We're going to use three different techniques today, making some measurements on an IoT device. First, measuring nominal power on a simple program. We're going to measure boot up energy as your IoT device comes to life, and we're going to look at the peripheral performance. Verify the power requirements of your peripherals that you might need to use in your IoT design. The first thing we're going to look at is the power on a simple program that lights up some LEDs. Let's see how we can make current measurements to complete that test.
We start our test with a zeroed current coming out of the current probe, and then we can turn on our device. Now we see current being drawn through the device in level steps. These are related to when the LEDs turn on. If we zoom in, we can see four different levels where the LEDs are turning on and off, related to current levels between about 5 milliamps and up to 40 to 50 milliamps. So each step is about 10 to 12 milliamps. This is the current being consumed by each LED, on top of the current being consumed by the CPU running internally to the IoT device. This is a good way to start our investigation of power levels being used within our IoT test. We monitored the current consumption of our basic IoT test using an RP1002C current probe and our 4000 series oscilloscope. Together, we were able to set the correct values to view the current in real time as the LEDs on the test board were going on and off. Next, let's look at the energy consumed during a normal boot up process of an IoT device. This test is set up to capture the current pulse from the initial boot up of the IoT device. As we turn it on, we can see a current pulse in the yellow. Zooming in, this current pulse is about 25 microseconds long and peaks at about 2.87 amps. As we see that initial boot up energy go into the device, the voltage rail droops slightly. But on this scope, we can also calculate the energy overall using the purple trace here. This is the current times the voltage integrated over time. And we can see that most of the energy usage is really in that initial 20 microsecond boot process. So this is a great way to think about how your device boots as part of your overall energy consumption, maybe coming out of a sleep state or just a direct hard boot of your IoT device. There, we measured the energy consumed during a boot up sequence for our IoT device. We've been powering our IoT device with a DP832A power supply. In our final test, we're going to go one step further and start to look at the power requirements of some of the peripheral devices, like serial communications. All right, back for our final power consumption technique. Now we're looking at the SPI bus, serial communication, on our IoT device. We're set up to monitor traffic on the SPI bus as well as current being consumed. So we can see here the packets coming out at a consistent rate. Let's trigger over to channel 1, and now we can see the current. So we can see what's happening is the current isn't being drawn into the IoT device in a DC fashion. We're getting small pulses every about 1 millisecond that consume a lot of the power. So that's charging something up on the device, and then the battery, and then it's being used in a more consistent basis by the SPI peripherals, by the CPU running inside, and anything else you have running. So all that's working together, but you need an instrument like a scope and a current probe to really see all the current being drawn into that device, because it can't be monitored with a DC multimeter. So now we see, in addition to what we saw in the boot up sequence and what we see kind of nominally from things like LEDs, we can see additional current being drawn in a pulse fashion into our IoT device. So all that works together to really make a decision about your power consumption and really ways to optimize your code to get the most out of your IoT device. There we demonstrated how to test the power requirements for a peripheral on an IoT device like the SPI bus. Combined with the nominal power usage and the energy consumed during boot up, we have a complete profile of our IoT device's battery requirements. Together, we can take all that information to build a battery life profile for our device as we go to market. In this test today, we used a 4000 series oscilloscope, a DP832A power supply, and our RP1002C current probe. Together, these instruments make an affordable package for IoT power testing.